Okay, so what we're going to go over is 1.5, and we're going to go over slide 11, which is the takeaways. So I'm going to say the takeaways, but I want you to know that if you didn't get all of these, that's okay, because that's just the first round of us going through this. And that's why I like going over homework over and over again and like kind of leaving it open on when I actually grade it. So you have a lot of time to go back and re-look through it to make sure that you're, that much more strong on that. Okay, so the first thing that I want to talk about is the graph of the function. And I'm on this slide, but I'm going to be drawing all over here. So what is the shape of the graph of a quadratic function? That's going to be like that. Oops, sorry, hold on a second. I'm in highlighter mode. I didn't realize. That's going to be that parabola looking thing, right? Sorry, this isn't perfect, but this is going to be that parabola looking thing that looks like this, right? Okay, so that's what a quadratic function looks like. And when I say quadratic, your brain should really be thinking of x squared, okay? X squared. In terms of a table, you would see this as, and you've seen this before, when we look at quadratics, I think about the eyes. Remember what was that back in I rule? Remember this, where is it? Sorry, the eyes. I'm looking for this part right here. Yeah, this, remember? And then when you were adding these, the table here, right? The table here was going, like this first table was just going up by 5. That meant it was linear because this was all the same. I know, right? All the same. But then when we got here, this is the one that I think about Jade's, where she was like, Ms. Johnson, I see the just a bunch of squares over and over again. And I'm like, yes. And so when you looked at that table, and I wish I can bring up that table right now, but I don't have it. It's not going to have this same number here. And in fact, if you remember what it was it was being added like by the odd numbers, right? And so when I think about what the table looks like, it's not the first row of constant differences, it's the second row of constant differences. And I'm going to explain that really quick. Second row of constant differences. And so that means over here, so if I drew just a quick table, let me just do a quick table. And I don't have, you know what, I will do 7n squared because that's the one that you guys used before. When I plug in 1, I get 7. When I plug in 2, I get 28. When I plugged in 3, I get 63. When I plug in 4, 16 times 7. 16 times 4, sorry. Yeah, 16 times 7 is 70, 98. Okay. So then if I look at these differences here, so let's see, this is what, 21, this is what, 40, 35, and this is what, 30, 20, wait, 30, what? 35, wait, did I do that wrong? I probably did this wrong. Hold on a second, guys. Let me multiply. This is what happens when I do things on the fly, y'all. Okay, so 7, so 9 times 3, 9 times 7 is 63. 16 times 7 is not 98, Ms. Johnson. It's 112. So this is 112. So then 112 minus 63. Okay, that's 49. Okay, that makes more sense. Okay, if you notice here, these numbers are not the same, right? These numbers are not the same. So then I'm gonna, okay, well, let me subtract again to see. You've never seen this happen, so don't worry, like, hey, Ms. Johnson, what are you talking about? So I'm gonna subtract these again to find what the differences are here. And you'll notice that this is a 14, and this is a 14. So these are the same. So when I say things like the second row of constant difference, the second row, see how it's the second row of differences is the same? That's what I'm talking about. Okay. Okay. And then the rate of change here sounds funny, but the rate of change is linear. Oops, I'm writing again here. And what do you mean by linear, Miss Johnson? Hold on. So the rate of change here, looking at this rate of change here, notice it's going up by the same number. So because the rate of change here is the same here, then we call this rate of change linear. This invokes a linear pattern, not my original numbers, right? Okay. Okay, so let's do exponential. So what does exponential look like, Ms. Johnson? Well, exponential looks like this, right? It starts off really, really close to the x-axis, and then it hits 0,1, and then it takes off. And this is what people would say is exponentially, it's exponentially growing, okay? So your base function looks like this, 2 to the x. Now look, these don't say the same thing. These two things do not say the same thing. Just like the word no and on don't say the same thing. But Ms. Johnson, it's the same numbers. Yes, but order matters, right? No and on, same letters, different words. Like imagine if you asked me, hey, Ms. Johnson, do you want sushi? Just kidding. Sorry. I just thought that was funny. Okay. Hey, Ms. Johnson, do you want sushi? And I'd say on. And you're like, what's wrong with you, Ms. Johnson? That's not even a response. So, so does that make sense? So we would say things like no, or we would say not on, because on does not mean the same thing as no. Okay. What about the table? So the table, if you think about that, now I want you to think about, let's see, is it, I don't know where it is. I'm just going to leave it like that. The table for this guy, it's not being added, right? It's not being added. In this case, it's being multiplied by 2. So I'll find that later, but it's being multiplied by 2. So here there's a constant ratio. There's a constant ratio, And I'm going to use the word multiplier, because that helps you remember that we're multiplying, multiplier. Okay, it's a constant multiplier. Okay, and then the rate of change for this guy is exponential. It's exponential. Okay, so there you go. That's my little table for this one right here. What I really wanted you to get kind of like in your head for this whole unit, for this whole lesson right here was this. Oh, did I write that? No, I didn't. Was this. Number one, these two graphs look way different, right? Number two, the equations, please don't say they look the same, because they don't, right? On and no, right? And then the last part is how does the tables look? Like this is what a table looks like for this. Let me draw you a table. Let me create a table really quick for exponential. So if I do 2 to the x, it would look like this. 1, 2. It would be 2, 4, 3, 8, 4, 16, 5, 32. Notice it's just multiplying by 2 every single time. It'll show up. So the tables look different because it's not going to be added, or even the second level added. It's going to be multiplied. So like this number is going to grow by a factor of 2.